Watch how they move something as massive as a crankshaft. This step shows technicians lifting it from the bed plate into a transport cradle. It's no simple hoist. Special rigging, alignment checks, and teamwork make it happen. One wrong move could damage the entire engine. Heavy-duty precision right before your eyes. Need to secure drinking water for the long haul? Here's how it's done underground. This modular tank system by Amablue uses GFRP, glass fiber reinforced plastic, segments with diameters up to DN 3270. Each prefabricated chamber fits precisely with sealed joints that meet strict potable water standards. The Kreglingen project features a multi-chamber layout with integrated valve control and individual access points. Installation is fast, thanks to its lightweight and smart modularity. Every detail, from UV resistance to upgrade-ready connections, is built to last. Watching each segment click into place is oddly satisfying. This isn't just infrastructure, it's future-proof water security. Coil spring manufacturing is more intense than it looks. Cold winding starts with pulling pre-tempered chrome silicon wire through rollers, forming tight coils on a ground arbor. For heavier duty needs, hot winding heats bars to 1,750 degrees Fahrenheit before coiling, quenching, and tempering. Every step is monitored to meet exact specs, because spring failure isn't an option. It's not just heavy, it's critical. Watch this massive crankshaft get loaded onto the DB 12500 grinding machine. A special hoist lifts and aligns the component with millimeter precision, because one slip could ruin hours of prep. Each move is calculated, each swing deliberate. This isn't just lifting, it's a delicate choreography of weight, balance, and industrial mastery. Steel this thick doesn't break easily. Watch as 3/8 thermal lances slice through massive rolls in a fiery show of industrial power. Laser cutting steel into an arch shape boosts precision and prevents deformation. This factory commits to laser cutting, turning high cost into high performance. Take a look at the KSS 1600 in action, an inclined bed circular saw slicing billets with clean, consistent force. The carbide-tipped blade powers through dense material effortlessly. It's not just cutting, it's high-efficiency transformation of raw steel into ready stock. Ultrasonic testing sends high-frequency sound pulses, like sonar, into steel components to detect internal flaws. It's fascinating how invisible waves reveal what the eye can't see. From lab samples to heavy-duty axles, this non-destructive method ensures safety where it matters most. "3D printing, also known as additive manufacturing, lets engineers redesign turbine parts with cooling channels built inside. This reduces cooling air demands, saves fuel, and helps turbines run on 100% hydrogen without sacrificing durability under extreme heat. This starts as a flat copper disc, but watch closely. A skilled operator mounts it onto a mandrel, and as the lathe spins, he uses forming tools to gradually shape the vase. No molds, no casting. Just pressure, rotation, and precision. This process is called metal spinning. With each pass, the copper flows, thinning and stretching into its final form. It's hypnotic. The control, the force, it's both delicate and intense. Pure craftsmanship meets raw material. How do you bring old wheel sets back to life with modern precision? It begins with check-in and a detailed preliminary condition assessment. Based on actual findings, a tailored maintenance cycle is planned. Each component is digitally traceable. The wheel set is then disassembled, and the axle undergoes reprofiling. Automated thermal spray repairs rebuild worn surfaces. Structural integrity is assessed for recertification. Critical components are optimized. Gearboxes are overhauled and tested. After reassembly and original spec confirmation, automated inspections ensure quality. Finally, custom racks protect the wheel sets for shipping, while the entire life cycle is digitally recorded. How do you lift 25,000 tons of steel in just 9 seconds? The Brent Bravo platform, once a giant in the North Sea, was lifted in one shot, using 6 massive arms and precise ballast control. Shear keys and diamond wire cutting freed it from its base. A specialized vessel navigated under, latched on, and hoisted it in one smooth motion. The topside was then transferred onto a barge and towed 700 kilometers to shore, where 98% of it was recycled. That's engineering mastery in action. You won't believe this wheel started with sand and a blast of gas. The process starts with preparing the carbon dioxide sand cores, compressed sand mixed with sodium silicate and hardened with carbon dioxide to form internal cavities. These are precisely placed in the mold cavity, which is then closed and clamped. Molten aluminum alloy is poured into the mold at high temperature, typically around 700 degrees Celsius. As the metal flows in, it fills every detail of the cavity and core shape. Once cooled, the sand mold is broken apart, revealing the raw casting. It's incredible to watch workers extract the wheel, still steaming, before trimming off excess material. The casting then moves to fettling stations for surface cleaning and edge smoothing. Finally, it's inspected for defects and dimensional accuracy. Each wheel undergoes rigorous quality control before moving on to machining or coating. From just sand and molten metal, a precision product is born. Seriously satisfying to watch. This isn't your typical torch cutting operation. At Cogmatic, flame machining takes center stage, literally. Instead of relying on basic XY burn table motion, their proprietary system uses a precision gearbox driven by a profile cam, custom designed from exact tooth specifications. The result? Smooth edges without the jagged burn marks you'd usually expect. The difference is clear the moment you see the finish. It's sharp, clean, and made to last. And it gets better. This process is not only faster than cold machining, but also more precise than traditional flame cuts. Plus, it's cost-effective for prototyping custom gear and sprocket designs. Mud relief notches in crawler sprockets? They do that too, sometimes cutting both sides in one go. Once the part is shaped, it's time for heat treating. Their upgraded spin induction system handles parts up to 60 inches wide. A powerful magnetic field induces current into the metal, heating it to transition temperature. Then, a temperature-controlled quench locks in hardness. Their system saves past settings and adapts for new orders, even one-offs. With consistent in-process measurement, carburizing options, and sample testing, every part meets demanding specs. Recycling copper isn't just smart, it's essential. Glencore's operations recover copper, gold, silver, and more from end-of-life electronics. Instead of sending e-waste to landfills, they reclaim valuable metals through advanced smelting and refining systems, reducing pressure on mining while keeping these materials in the industrial loop. What does it take to forge a wrench that stands the test of time? At Jonesway, every wrench begins as premium steel sourced from Taiwan's leading steelmaker. It's heated to over 1,000 degrees Celsius, then elongated on a rolling machine, enhancing strength and reducing internal stress. Next, the steel is forged in 3 precise die pressings to shape and cut the blank. The raw wrench is submerged in a chemical solution with ceramic stones for initial grinding. For mirror-finished models like the W26, a technician then hand polishes the surface to perfection. Stamping follows, engraving the logo, size, and item number while simultaneously strengthening the metal. Heat treatment then hardens the tool, and sandblasting clears carbon residue, prepping the surface. The wrench now undergoes a second chemical grinding for a flawless polish. At the open end, a 3-stage grinding process refines fit and contact precision. Extra care is taken to ensure tolerances are tight for high-torque use. Lubricant residue is cleaned off completely. Sharp edges, left from earlier shaping, are carefully removed. Each tool is visually inspected during this stage for visible flaws before proceeding. Plating comes next. Their specialized technique deposits a durable coating that resists corrosion. This isn't just about shine. It's about long-term protection in harsh working conditions. Before moving on, every plated wrench is also weighed and dimension checked to ensure consistency across the batch. To verify quality, the wrench is then subjected to a salt spray test. 48 hours of atomized salt exposure. Only rust-free samples pass. Final inspections check torque strength and surface finish before packaging begins. Each wrench is individually packed at dedicated stations to avoid mix-ups and allow one last quality check. This isn't just mass production. It's craftsmanship meeting engineering discipline. Every step reflects purpose, precision, and pride. Massive gear casings are milled with power. Each pass feels thunderous, precise. At Sandusky International, massive centrifugal castings are machined on large lathes to meet extreme heat and corrosion demands. With world-class surface finishes and seamless designs, these alloys power industrial systems globally. Beyond metal, every turn delivers reliability forged through purpose and skill. Here's how Keegan Precast transforms digital plans into massive, high-performance wall and floor panels. Each one begins as a detailed 3D model packed with cutouts, reinforcements, and embedded components. Once approved, data flows directly into the factory's automated carousel system. Steel pallets are plotted with laser accuracy. Magnetic shutters are cleaned, oiled, and positioned to form perfect concrete edges. Electrical boxes and conduits are glued in place. Reinforcement spacers follow. Then a robotic machine bends and places rebar with astonishing precision, every link matching the digital model. LCE girders are added to connect the wall's 2 skins. After tying the steel and placing lifting hooks, concrete, batched on site to EN 206 standards, is evenly spread by a mechanical distributor. Oscillating platforms compact the mix, producing a flawless 40-Newton finish. Cured panels re-enter the system, flipped and aligned for skin-to casting. Once bonded and re-cured, twin walls are lifted by custom cranes, tilted vertically, and loaded with care. Every slab and wall reflects the system's speed and strength. Everything moves with quiet certainty. No guesswork, no hesitation. From first cut to final fit, every movement here follows a system. Magnetized lifters handle each blank with care, feeding them into press machines that shape them with ton-force precision. Multi-head tapping, welding, and surface treatments follow in seamless flow. Gravity trolleys move components in single-piece fashion, keeping idle time minimal. Data displays monitor PT and oven temps in real time. Measuring stations and tool racks keep quality in check. Meanwhile, grinders, lathes, and CNCs in the tool room maintain the heartbeat of the line. This isn't just fabrication. It's a system built for consistency. A single 96-inch aluminum sheet is spun into a flawless 93-inch bowl on one of the largest metal spinning lathes in the US. Watching it form is oddly mesmerizing. Gold sponge is loaded into a crucible and fired at nearly 2,000 degrees Fahrenheit. Within minutes, it melts into a glowing pool. The crucible is lifted, and pure gold pours into a graphite mold. Watching liquid metal become solid value, it never gets old. Crankshaft machining starts here, with automated cuts, precision drilling, and smooth surface finishing. Each pass follows CAD CAM instructions down to the micrometer. Precision like this doesn't just happen. It's built cut by cut. How do you assemble and weld massive steel beams with zero manual welding? Here's how SBA Compact turns CAD models into fully assembled, robotically welded beams. It begins with CAD design and digital programming, where every angle, hole, and weld path is calculated for maximum efficiency. Once data is transferred to the system, ADD parts are placed, scanned, and rotated automatically to the correct orientation. The main beam, whether an eye profile, rectangular tube, or SIN beam, is then loaded onto the line. Robotic arms handle everything from auto positioning to full assembly, adjusting tools autonomously depending on the part type. Auto-turning features rotate components without manual input. A vision system tracks part geometry and surface reference points, ensuring alignment before each weld. Meanwhile, the system logs all key parameters: temperatures, voltages, positions, for traceability and quality control. Sensors confirm every part's position before the system moves forward, reducing error to near zero. The preheating step isn't just about temperature. It ensures material integrity during multi-pass welding. Throughout the process, real-time checks maintain dimensional accuracy, weld quality, and system stability. Tool changes happen mid-cycle without pausing production, keeping output continuous and efficient. Before welding, the system preheats joints as needed. The robot then performs multi-pass welds with consistency and precision, even on complex geometries. Torch tips are cleaned and recalibrated automatically after each operation, ensuring every seam is strong and consistent. Once weld-out is complete, the beam exits the station, fully assembled, accurately joined, and ready for the next stage of construction. There's no pause, no guesswork, just smooth, synchronized motion from blueprint to beam. How do you build a ground floor that insulates like foam but stands like concrete? Here's how WarmFloor Pro combines expanded polystyrene and pre-stressed concrete beams to create a strong, energy-efficient floor system. The process begins with EPS top sheets and insulation modules, cut to size and laid out to form a thermal layer. End blocks are inserted to close off edges. Pre-stressed concrete beams are then placed into the gaps, locking into the insulation modules for structural support. An optional closure block seals the perimeter, completing the framework. The result is a floor that's thermally insulated, structurally robust, and ready for screed or further finishing. Designed for both domestic and commercial builds, it's moisture-resistant, rot-proof, and sustainable. It doesn't just meet thermal regulations, it simplifies the process and cuts construction time dramatically. WarmFloor Pro turns what used to be multiple trades into one clean, integrated install. Unexpected sparks fly as molten aluminum contacts a damp surface, steam, a flash, and chaos. Workers scramble, safety systems engage instantly. Fire suppression kicks in while alarms scream. Cameras capture chaos. Intense heat, frantic evacuations. It's a brutal wake-up call. Safety protocols can't be ignored in high-risk metalwork.